Now that our collider works, so it's enabled and disabled at the right moment, and that in here it's basically called, at the end of the image opponent function, we want to call the event that is going to take care of playing the animation montages of the heat reactions. So let's go over to the police character, let's go to the event graph, and right click and say add custom event. We call this point the image, and we want to have one single parameter in here, which is going to be a capture collision reference, and we're going to call it collider. Once this is done, we can compile, go back to our support character, and out of here we can say, we have to grab the opponent reference and say point the image, and here it is. We will have to connect it to that pin and then grab our collider. Oops. Because this is the collider that is basically firing all this. So that this event is going to be called. So once the event is called, we have to calculate the two vectors that we need for using the dot product. The first vector is going to be the direction of the mesh, so where the enemy is facing at the moment this event is called. And the second one is the direction of the right vector of the collider that is hitting the enemy. So for doing that, we will create a couple of functions, and we can call them get enemy direction, and the second one can be called get collider direction. Now this one is going to take an input, which is the reference to the capture collider. Here we go. Let's compile and go over to get enemy direction. In here, what we want to do is calculating the right vector of our mesh and then store it inside a variable. So first of all, let's create that variable. We will call this character direction. And obviously, as you may have guessed, the variable is going to be a vector. Then drag it out. And this is going to be set to get word location, then get word rotation, can't spell. Then we will get the right vector again, and the reason why I repeat it once more is that the right vector is the one facing forwards in the mesh, and that's the reason why also the colliders are using right vectors. Then, oops, we were in here. After this, we're going to basically add these two vectors and then subtract these two vectors. So to create a vector, which we hold simply the direction of the vector starting from where our character is, and the value that is going to hold is going to be between 0 and 1, which is perfect for calculating our dot product. The same holds true for the collider, direction collider. So what we will do is just copy and paste this over here, since the code is basically the same, and we will connect the collider to these two pins. And we will have to create a new variable called collider direction, which is also a vector, and set it to the value we calculated here. Let's compile and go back to our event graph. Next, since we created these two functions, we better using them. So we just drag and drop them here and connect this to the collider. After this, we want to calculate firstly the dot product before continuing. So we grab the two vectors we just created, the two variables, and then we want to normalize the variables before calculating the dot product. The dot product can only be calculated on normalized vectors. Then we will type dot, and here is the dot product function for us ready. We want to check the values out of these functions. So out of this pin, we're going to drag out and say in range float and copy it and paste it basically 3 times. One is going to be for the forwards reaction, one for the backwards reaction, and one for the left and right. The values in here, I already basically experimented with the values, so I already know more or less what are the values. So between -1 and -0.7 is going to react forwards, then between 0, 7 and 1 is going to react backwards, and between minus 0, 7 and 0, 7 is going to be either left or right. We will calculate that with a cross product in a second. Now let's branch here, and we'll have to branch actually 3 times. So if the first one is true, well, the true pin is going to run, otherwise we go to the next one, and the same goes for this one. Let's compile and create a variable of type hit type. If you remember, we already created an enumeration at the beginning, so all we have to do is say hit type, and here it is. We'll have to track this here and set the value once and twice for forwards and backwards. Now we will have to calculate actually the cross product if we want to find out if it's basically to the right or to the left. So we'll have to do the same thing here. We could have just copied and pasted all this. After this, we're going to say cross this time, and the cross product is going to return, as I told you before, a vector. So we want to break that vector and find what the z value looks like. We're going to compare it to 0 and say if it's less than 0 or if it's more than 0. So out of here, we will have to branch again twice, and this is going to be the first condition. This is going to be the second condition. So if it's less than 0, then it means we're going to the left. If it is more than 0, we're going to the right. Here we go. So now that we set all the values, what we will do next is switch on hit type to check what the value is, what value basically is contained in this variable. We have obviously to grab hit type and connect it to selection. So for each one of these, we will have to set a variable that we create now, an animation montage variable. So hit reaction montage. Let's set it to be an anim montage reference and copy it and paste it 4 times. Here we go. And connect these pins to each one of the instances of the variable. Then all we have to do now is setting these variables to the right animation montages. So hit forwards is the one I created before. Hit, oops, sorry. Backwards, yes, this one is the one. Hit, this one is right. Hit right, and lastly hit left. Once we set all the variables to the right and montages, what we want to do is simply say play anim montage. Connect all the pins, and obviously the value is going to come from this variable. So connect this variable to the anim montage pin. After this, what we want to do is just say percussion, because I don't want to mess anything up later. Just set back this to empty, just in case, and compile. Now that we connected all the montages, let's test this out and see how it works. Okay, it reacted as expected. Once more, and the last one should be the backwards one. So now, at the time you will try this and you'll test it out, the likelihood of it not working is very high. Let me tell you the reason for this. There are many things that play a part in the whole system. what we built so far is not even the entire system, but there are already so many things that may make the system not work, such as the direction of the punch, such as your animation, your vector is not positioned in the right way. There are many things. So what you'll have to do is some debugging in order to get all the values to work right, everything to be positioned in the right way. If I look at my animation, for example, just right before getting back to you, I tried this, I tested the code and it wouldn't work. The reason for that, it was, for example, that I had a big gap here. So the punch was enabled right here. And already at this point, vectors were drawn out. And it was getting this vector instead of getting the vector that I wanted to use, which is this vector here. At this point, I want to get the right vector. I don't want to get it before. So if I punch the police officer and I'm already within the range of the capsule and the punch is at this moment, you're already getting basically vectors out here. And that was the reason why it wasn't working. So this one is one thing you could get wrong. Then there are many other things you could get wrong. What I can tell you is that go back on the debug line trick I showed you before. Check that your vector, basically your right vector, is drawn in the right direction. Check that everything you've done so far is the same as mine. And then if you can't figure out, there is also other things you can do, like this. You can just type in here show collision like this, and as you'll see here now, all the colliders are drawn, so you can see if maybe the capture collider is too small of the enemy, so basically your punch is not detected. This may occur as well. Imagine just that this collider was wrapping the enemy this precise. It doesn't get basically the time for starting to overlap and then check for the hit. You will go through the mesh and no punch will occur, no hit reaction will occur, such as in this case, see? So you have to be careful, you have to set everything up in the right way in order to get it working. So if it doesn't work, just don't panic yet. Try to debug, try to look for these most mistakes and use the trick I show you, as well as this show collision. For bringing up the console, you have to press basically the opening single quote or the backtick, I don't know how you call it, it's before the number 1 key, and it's going to bring up the console as I showed you before, well, while you're playing obviously. And you can type show collision, there it is, just click and it's going to show you all the collisions around you so you can see basically what's going on. This is very helpful. So far we created the hit reactions, and as you can see, all we're doing is basically just calculating these two vectors. So we compare the right vector of our enemy and then the right vector of the collider we're basically using for the animation, and these are touched on one of the limbs. Once we compare them, we get some values out of the dot and cross product, and we can determine if the hit comes from forwards, backwards, right and left, and then we just play an animation montage. However, it doesn't look so good so far. The point is that we're not enabling any physics, so obviously there is not physical reaction from the police officer, and that's what we're going to build next. So on to what we've done so far, we're going to now enable and disable the physics at the right time. So far we based our physics reaction on the new physical animation component from Unreal Engine 4.13. So what you'll have to do firstly is go into your enemy blueprint, actually to your enemy character, to the skeletal mesh, and you'll have to get a physics asset. It's most likely that you already got one of these. If you don't, just right click, go to create, and then you have to say physics asset. It's going to come up with this, just say OK, and it's going to create one for you. Now there is a problem with the one that comes automatically with the skeletal mesh, or the one that you just created. It's not going to look nothing like this. And when I say nothing, I mean it. It's going to look very much different. Colliders are going to look completely different. And probably the same way, if I just simulate, it's not going to react in this way. It's going to go all over the place. It's going to react in a very weird way. Now, the point with this is that it takes some time to set it up, but it's not difficult at all. There are many tutorials on how to do it, and there is actually a series tutorial from Unreal Engine itself. I'm going to link it in the comments below so that you can check it out and see how I set it up. However, what you want to achieve is what you've just seen. Once you click simulate, you shouldn't see any unexpected behavior. The key point is, if you get any unexpected behavior in here, just don't go ahead. It's not gonna work. So whatever is going wrong in here is going to be wrong also in the game. You can't expect to have something like weird happen here and then the game running. Now, let me introduce you to the new physical animation component. What they did is introducing the concept of profiles, which is what you see in here. I already created one, but I can actually just bin it, and then we're gonna create one together. So what this is basically a bunch of values that you can use on a bond or set of bonds in order to correct the animation. Let me show you what I mean by that. In this case, I only want to have the physical animation component to behave and to basically take control of the upper body. So if you notice from the left and right fig ahead, I just set all these physics type to be kinematic. Which basically means that the animation is going to take over, is going to control this part of the body. The same holds true for the pelvis, and I think also for spine too. But from spine 3 ahead, I set it to be default. So all these are set to be default. Default means is basically what you assign during runtime. So if I press play right now, as you can see, the lower body is not moving. Okay? And, well, the upper body is just like dead. See how it behaves? It looks he has not life at all. It doesn't try to basically react. It doesn't try to correct what I'm doing. It just allows me to do whatever I want. Now, let's click again here on simulate and create a new physical animation profile. I'm going to call it physics. You can call it anything you want basically. Then we will select this set of bonds. We want the physical animation component to take over, and we're going to go here to profiles, set physics, and did you see that? Now we are allowed basically to add a new profile. You add the new profile and then you basically enter a bunch of values in here. I already tested these values and they actually come from another video, from a tutorial from Unreal Engine, and these values work quite fine. We don't want to have local simulation, and if now we press play, see that I didn't change any other settings. However, look at how it's trying to basically correct what I'm doing, because its position at the moment, its stance is he is in a T-pose, and it's trying to get back to his T-pose. If I go in here and I select any animation, let's select a walk animation, walking, and then I press play, see, he's playing his animation. However, if I try to redirect him, I'm doing this by holding down the control key and the right mouse button to stroke him basically. Look at that. He allows physics to take over, however, he's trying basically to apply some strength to correct the position and rotation of the bonds, so to go accordingly with the animation. Now, let's click simulate again and let's go back here. If you look at these values, they actually are quite self-explanatory. Orientation strength, angular velocity strength, these values are used to correct the position, the orientation of all the bonds which are set to have this specific physics profile. You can have multiple profiles, but one thing you have to understand, and I didn't get this at the beginning, is that the physics profiles that are just created is not permanent. All you're doing here is just testing. So this is basically your PHAT editor. All you're doing in the editor is just testing it. This is not permanent. once I close this, once I close once I close Unreal Engine, all the changes I'm doing here are going to disappear. As a matter of fact, this is going to be set back to none. So the point of the profiles is that they have to be set during runtime. That's how they work. You can set, that's the power of this new animation component. So to recap, all you have to do is basically creating one of these. So click here and create it, give it a name. And then all you have to do is making sure also that there are no reactions. And that you set to default, to kinematic, whatever bond you don't want to be affected by basically the physics, because they're gonna be taken over by the animation, and the rest of the bonds that you want to be affected by the physics have to be set to default, so that you can change the value during runtime. Now, let's go over to our police character, and let's add the physical animation component. Compile, and here it is. Actually, the physical animation component has one variable that really interests you, which is the strength multiplier. You can choose basically how much strength to apply. So if you type here 0.5, it will be half of the strength coming from these values. That's all it is. Now that our physical animation component is set, we can use it and we can enable it. We can basically enable physics. So let's go over to the support character, where we are going to enable the physics in the damage opponent macro. Once this runs, once this is finished and we set this to be false, so we break out of the loop, that's the point at which we want basically to set our physics. But the point is that if we don't use an extra variable in here, anytime this is completed, which is going to occur every single time. So if it ends here, this is going to run. However, we only want to run if this branch runs. And that's the reason why we're going to create now another variable called collision occurred. And we're going to say that this variable is going to be true only if this branch runs. We don't want to actually have a collision occurring if we didn't hit the mesh. Otherwise, this will run anyway. Then we're going to branch in here, and that's the condition we're going to use. Here we go. So all the rest is going to run only if a collision occurred. We don't want to run it if there was no collision. We want to keep looping and just do nothing here. Now that that's clear, let's go, and actually we have to first get the opponent, then get the physical animation. Let's see, physical animation is in here, and out of here we're going to basically get the set skeletal mesh component, because we have to specify which mesh is going to be affected by this physical animation. And here we go. Gonna connect it here, and after this we're going to say apply physical animation profile below, and the target is going to be obviously the physical animation again, and I'm going to say that it's going to be from spine 02, we don't include self, and the name of the profile, I believe it was physics. So all we're doing here is setting the profile. Remember, we created a profile. So now we're saying apply to these bonds. Then after these, we left to apply physical settings below. So we say which profile we want to use. Now we have to give it a bunch of settings we want to use on the profile. Spine 02 is our bond again. We don't want to include self. And again, is going to be the target is going to be the physical animation. Here we go. And we're going to make a struct, make physical animation data. And here are the numbers that you've seen in the PHAT editor. 1000, 100, 1000, 100. We stick to these numbers since they work well. And after this, we have to set all bodies below simulate physics. So all bodies below simulate physics, but not on this mesh actually, on the opponent mesh. Here we go. We have to make a literal name, and it's going to be spine02 again, connected to the bot name, and we don't include self, and we want to run a new simulation. Now we'll go and disable the physics in the police character. Let's compile first. And go over to our police character. In here, after all these runs, so after we reacted, we want to disable the physics. The way we do this is basically, well, firstly, I already experimented this, so I know that if I don't put a small delay, this is going to run so fast that we're not going to even see the physics running. After this, we want to progressively basically set the weight of the physics animation. Let me show you what I mean. So there is this value here, physics blend, okay? If it's set to 0, it means we blend in between animation and physics with just on animations. So we basically giving the work control to the animations. If it's set to 1, we basically giving full control to the physics. That's what this value means. And there is a node for setting between 0 and 1. So at the moment we set before the animations to run the physics, now this value is set to 1 by default, which means physics are going to take over the upper body from spine 3 ahead. But then when we want to disable the physics, what we're really doing, if we do just disable the physics, there is a node for resetting basically the physics and say just go back to animation, okay, no physics running. That will just give us the effect of something snapping back. So it's basically under the control of the physics and then it snaps back. We don't want that. We want to slowly blend back to our animation, and this value comes in hand. So let's go over our police character, and after this we're going to use my favorite macro, which we don't have in here. We're going to create it while loop with delay. Oh, sorry, I think there is one. Oh yes, I have it here. Sorry about that. So we have just to use the while loop with delay here, and now you'll see how we use it. So we need also another variable. We call it, I don't know, recover, but you can actually call it with something a bit more meaningful. And I'm going to set recover by default to 1 as for this value here. You may already have guessed what I'm about to do. And then we say as long as this value is more than 1, I want you to do something. So this is going to be the condition. The delay is going to be, I believe I'll use this value, 0.001. So we plug this execution, and then once it's completed, we want this value to go back to 1, to its original value. We're about to change this in the loop body, and here we're going to actually create another function, and we call it the save physics. And in this function, what we're going to do is saying let's set the recover to be the actual value, the current value, minus 0.1 every 0.01 seconds coming from the delay of the while loop. After this, we want to say, let's grab the mesh. We want to say set all bodies physics blend weight. No, this is not actually the node. Set all bodies below physics blend weight, so below a number of bonds. Here we're going to make a literal name again, which is going to be again spine02. By the way, I'm taking this from here, if you didn't notice it, and you have to spell it in the exact same way, otherwise it's not going to work. We don't want to include self because we didn't include it before, and we want to set this value here, physics blend weight, which is this value here again, this value here again, to the current value of recover. So once this is basically done, this is going to be run by the loop body. Drag and drop this in here. Here we go. We're going to reset this to 1. After this, we still have left in the support character the reset the mesh system. We didn't do anything here. So what we have to do is branch, then get the capture component of our enemy, compare it again to other, to see if this is what we hit, and if it is, we want to reset basically the 2 variables we were using in the mesh opponent. Oops, sorry. Here they are. So we want to reset them to false. Let's compile. Now that also the reset, the mesh system is being set up. I believe we set up everything for the physics to run. Hopefully I didn't miss out anything. So let's go here and test this out. And as you can see, I don't know if you noticed it, but he actually reacted. The body actually moved, so it's not getting through like before. Now I didn't detect it. I want to show you this a bit better, so I will go over here and disabling this so that it's not going to play any animation montage. Let's see how this works. And as you can see, my punch made it move. See that? Now it looks like it only works when it comes back, and that's depending on the animation montage I set up. As you may remember, I already explained you before that this is the point at which is enabled. So to get this to work perfectly, I'd have to play around with this to where they're positioned, so to where the collision is enabled and disabled in order to get it to work perfectly. But as you can see, also the physics work. And if we enable everything, it also blends back. So here you have your reaction system. This was all from your Dragonwall Studio tutorial. I really hope you found this video helpful. And if you have any question, just leave a comment below.